Have you ever been driving your car on the road with your friend and thought to yourself, my goodness, am I emitting so much carbon dioxide right now? And plus, all the planes, trains, trucks, and buses around me are doing the exact same thing. Well, I beg of you, do not fret, do not worry, and do not panic because we have some solutions available. If we can think like engineers and evaluate some of our options that we currently have, maybe we can think of a great solution to greatly reduce or even completely end our CO2 emissions. So today we're going to think about diesel in particular and look at if biodiesel or renewable diesel are climate change heroes or no-goes. So first we're going to define these terms, and then we're going to ask some questions about if we have enough crop yields to produce enough of these renewable diesel products, and or would that result in enough CO2 reductions. And then finally we're going to compare to other alternatives like solar and wind, and what is our time factor to solve climate change. To clarify, biodiesel or renewable diesel come from the same feedstocks, which is fat oils or greases, typically from soybean oil, corn oil, even used cooking oil, animal fats as well. Renewable diesel and traditional diesel look almost exactly the same. However, renewable diesel will have a higher molecular weight. Compared to biodiesel, it looks a heck of a lot different. So you have some double bonds with the carbons, hence that bend in the chain. You also have an ester group at the top. This provides biodiesel with some unique properties. The ester provides lubricity, so actually if you switch a vehicle from traditional diesel to biodiesel, you may clog the filter, and that's not the biodiesel doing it. It's actually the biodiesel lubricating and cleaning out diesel particulates left. Biodiesel is a little bit poorer of cold weather performance, but if you blend it with diesel, renewable diesel, those effects are minimized. Biodiesel and renewable diesel are produced from the same feedstocks, as I mentioned, but they use very different chemical processes. So both start with the same triglyceride, or a fat oil or grease. For production of biodiesel, it is reacted with methanol, a non-renewable chemical in most scenarios. Transesterified with glycerol as a byproduct, and then biodiesel as your main product. Or you can make renewable diesel by reacting with hydrogen, which is also kind of a non-renewable chemical, and then you're going to do it at harsher temperatures and pressures to produce propane as your byproduct, and then you're going to get your green hydrocarbon as well. You also have some water and CO2 emitted there. Petroleum refineries, however, are a little bit more complex since you have a lot more products being produced at the same time. I'd like to draw your attention to this desulfurization unit because sulfur can be an issue in diesel production, traditionally speaking, but it's not as much of an issue for renewable diesel or biodiesel. So what really emits more carbon dioxide? Biodiesel, renewable diesel, or petroleum diesel? Let's find out by using life cycle analysis. This is super easy to do because for renewable fuels, California has a special tax credit system that looks at carbon intensity, which is essentially an LCA. So carbon intensity is grams of CO2 per megajoule, the exact same thing you'd look at for a life cycle analysis, and that's how much CO2 is emitted per joule that you're actually producing. So for traditional diesel, it's about 100 grams per megajoule versus renewable and biodiesel, you can see they're lower than this line. There is a big range because it really does depend on how you produce it. But in general, according to Renewable Energy Group, their best CI scoring fuel is about a 24 gram per megajoule, which would be about like here-ish. And then for renewable diesel, the industry average is about, I think, 34 to 36. So it would be closer to like here, which is a very large reduction in CO2 emission compared to traditional diesel. You have to factor in land use changes into the CI score. So if you're converting a forest to a farm or something like that, there's a penalty you have to consider. And it's almost 30 grams out of the 50 total, which is kind of a lot. But throughout the train of making biodiesel, at least from soy, you would go from farm, transport to a soy crusher, transport your oil to get transesterified at a biodiesel production site, then transport again to get it to the customer. And when the customer burns it, you do not have to consider that in your CI score because it's assumed that all those CO2 emissions will go back to corn or soy, whatever's growing, and it kind of gets cycled around. So let's do some engineering analysis to figure out, is this really a good climate change solution? And my first question is, could petroleum diesel demand currently be replaced by corn, soy, and used cooking oil derived sources? So let's do the best case scenario. We're going to take each yearly yield of the United States for corn, soy, and used cooking oil. So you've got 14 billion, 4 billion, and 3 billion here. Convert it to pounds, and we're only interested in the oil fraction because that's the only fraction that can get turned into renewable or biodiesel. And let's assume that all of that goes to make fuel. Added up, it's 306 billion pounds of oil as the feedstock for the reaction, so it's time to convert it to the product via stoichiometry. For biodiesel, it's almost a 1-to-1 mass ratio. For renewable diesel, it's not. And then density, biodiesel is more dense. And then finally moving into the energy density consideration. So when you have 1.1 gallons of biodiesel, from an energy standpoint, due to that ester group, it's equivalent to 1 gallon of diesel, traditional diesel. Versus renewable diesel, it's a higher molecular weight, it's a paraffin, so it's a little bit more energy dense. And you can see that from the best case scenario, you could replace 80% of current petroleum diesel demand with biodiesel, or almost double that with renewable diesel, which is really good. But this is actually double counting. Some of this yields that we get from corn and soy and UCO already go into making bio and renewable diesel. So if you take that into account, you're down to 50% using biodiesel, or 100% with renewable diesel, which is still very good. But that would mean any of the other dispositions for these oil sources couldn't be happening. So more reasonably, let's say we direct 25% of each to start making fuel as of today. That would save us 20 to about 45% on our current diesel demand, which is pretty good. It's definitely not a majority, but it's a start. But say we wanted to go fully into the renewable diesel, biodiesel space and invest in making the new farms, how much land would that take? And my answer to that is kind of a lot. So if you did a corn and soy 50-50, it would turn into 10 Pennsylvania's worth of land, which is a 34% increase in U.S. farmland. For biodiesel, for renewable diesel, it'd be about 3.6 Pennsylvania's worth of land, or an 11% increase in total U.S. farmland. Note that corn has a higher yield because there's more bushels, more oil per given acre, but it also is not as great at fixing nitrogen as soybeans is for the soil health, so you have to consider that too. Let's think about CO2 emissions. How much could we really avoid if we switch to bio or renewable diesel? Well, it's going to all depend on our CI score. In the ideal situation, the basically money up for grab to get rid of all the emissions, it would actually fix 11% of U.S. CO2 emission issues, which is pretty crazy. So our goal is to get that 11% not being emitted. However, that's not possible because we have a CI score that's not 0 for biodiesel or renewable diesel. So in the best case scenario, if we could divert all of that petro diesel using these two options, you could at best reduce the CO2 emissions of the country by 7 to 9%. Or if you look just at diesel, from 65 to 83%. That's a lot. That's a huge savings of CO2 emission. However, that's not necessarily realistic with our current land available. So if we took our 25% cases and see how much we could save in terms of CO2 emissions, that would be seen right here. So if we did that, you could save 2 to 3% of the CO2 emissions of the U.S., and that would be about 20 to almost 30% of petrodiesel emissions. So a pretty good amount on that would be like a base case scenario. But if we really invested in extra land in terms of farming, it could be done. There might be better options, and how quickly could those be implemented? Let's find out. So for solar and wind, they have a CI score of 0. And they would actually require pretty big infrastructure changes to implement. We need a lot more Teslas on the road, and we necessarily couldn't power planes. So I propose that biodiesel, renewable diesel, though their CI score is not 0, they can really help us speed up this energy transition because there's minimal infrastructure changes that need to be made. Existing diesel engines can still be used, and even refineries can convert their hydrotreating units into renewable diesel production sites relatively quickly. Some companies are planning to do this by 2024 or expand their current operations in this field. And renewable diesel can definitely power planes. So I suggest doing a balanced approach of these two sources to further diversify our renewable energy options and make sure everybody kind of gets a piece of the pie in the end. I'm very happy we were able to define all these new terms we learned and ask some questions about, is there enough crop yields? Not really, but it would result in a huge CO2 emission savings. And in a comparison, solar and wind are probably good options to invest in for the future, but biodiesel, renewable diesel can really do us some great favors in terms of aviation and trucking industries, and where electric vehicles aren't quite there yet. So hopefully the next time you're driving in your car, blasting your music, zooming down the road, you think to yourself, I can be a climate change hero. Now that I have all this knowledge, I can inform others, and I can be an advocate for these types of solutions. Also, if you're interested in biodiesel, renewable diesel, solar, wind, anything renewable, you can get involved with those with your career as an engineer. Your possibilities are very wide open. So thank you very much.